In this video, we're going to focus on FRQ 3, experimental design. My favorite, it's a 10-pointer, very predictable points. Look at part C, there's 4 points there, so it's a tenth of your FRQ points. Right in this question, and all it is can you linearize an equation and can you make a graph? Very gettable. All right, let's look at point by point. Whenever you're designing an experiment, the very first thing you need to do is derive an equation. Once you derive that equation, linearize it. Figure out what your slope will be. And we want our slope to be what the quantity they're asking for is. If they want g, then we're going to figure out what do we need to graph on the y and x-axis, so that way our slope is equal to g. If it has to be equal to 1 over g, okay, square root of g, okay, but ideally we want it to just be equal to that. So that way when it comes time for us to figure out that slope, we can just say, calculate the slope of the line. So part A is all about designing your procedure. When you describe your procedure, short bullet points, getting straight to the point. Use the method measure blank with blank. In the first blank, you're going to say the quantity. So from your derived equation, if you have v for velocity, then you would say measure velocity with velocity meter. Maybe you forgot what actually measures that velocity. You forgot the word motion sensor. That's okay. Stick meter behind it. Force meter. Velocity meter is fine. Speed meter. Thermometer. Alright. Remember that something should be varied across your trials. That independent variable thing. For the second point, you have to do something to reduce your error. It might be repeat trials. It might be taking repeated measurements. Whatever's appropriate for your experiment. We've done enough experiments that I trust you know what's appropriate. Part B, 2 points again. This time we're going to continue on our experiment. You get the first point for saying which quantities should be on the axis. So the question is going to say which quantities go on the y-axis or the vertical axis and the horizontal axis to produce a graph that can be used to calculate this whatever. And then the whole idea is it's lining you up or leading you to making this y equals mx plus b graph. So make a straight line graph, ideally. Don't forget to mention the units whenever you talk about axes. Point 2 is how are you going to get the desired quantity? Are you going to take the slope, divide? If you're going to need to take the area, then you're going to multiply your two axes. Part C, the big one, you're going to get an entirely new situation. Sometimes you'll be given an equation, sometimes not. But if you're given the equation, you should linearize it first. Also, if you're stuck on part A, you're not sure, the situation in part C usually is different, but it might also be kind of related. So maybe something is going to pop up in your memory and say, oh yeah, spring constant, you can use Hooke's law and conservation of energy, so work. Those sorts of hints are what I'm thinking about. All right, so the first point, you need to linearize the equation and say which quantities go on each axis. Sometimes you'll have the y-axis already given to you, so it's already telling you how to set up your equation. Sometimes the x-axis will be given to you. Sometimes no axis will be given to you. Whatever it is, just make sure you label the axes and you have units. For point 3, make sure you have a correct scale. How much is each box worth? You don't have to label each box. You don't have to say 0.2, 0.4, 0.6. You can skip some and just show me where 1 is and show me where 2 is. That's fine. As long as we're using multiple numbers on each axis, you'll be good. Also, use the whole graph. Don't have a really super small graph. I haven't seen issues with that this year, anyway, the time of this recording. But good practice, and sometimes there'll be points in question. Finally, the last point is to plot data points. The data that they give you might be what you just need to plot. You might also need to do something to that data before you plot it. So maybe you were looking at a pendulum and the period is given to you and the length of the string is given to you. Well, what you really need is period squared. So in those empty data boxes, you are going to square each period, and then you can write them down, so that way you can plot t squared on your axis. For point B, 1 point for drawing a line of best fit. Probably going to be a straight line because of the linearization that we're going to do. We're linearizing. So a straight line, make sure you use a ruler. Make sure your line of best fit represents an average of the data. Have as many points above the line as you have below the line. They're not all going to fit on the line. And then calculate the slope will be the last point. Or the area, I suppose, using points on the line, not data points. That's it. You can do it.